The last section we'll learn about transformations is called compositions. Composite transformations are two or more transformations combined to produce a single transformation. You have to perform each composite transformation in the order specified. For the first composition, we're going to rotate 90 degrees and then reflect over the x-axis. First, I would want to write down my original points. So A is at 3, 7, B is at 6, 4, and C is at 2, 2. Then I want to use these points to rotate 90 degrees. Remember the rule for 90 degrees is negative y, x. So we're switching the x and y coordinate and we're changing the sign of the first one. So for A, when I switch them, I get 7, 3, and then I want to change the 7 to be negative. For B, when I switch, I get 4, 6. I want to change the first one so it becomes negative. And C, when they switch, I get 2, 2. And for the first one, they become negative. Notice that my second set of letters have the double apostrophe, which is said double prime. And that means I want to use these points now, not the original. So I'm going from my first transformation. So this time I'm reflecting over the x-axis. So you are more than welcome to put it on the graph and count, but I'm just going to use the rule. And so when we reflect over the x-axis, the x value stays the same, the y value changes, and notice that they stay in the original spots. So this time I would have negative 7, 3, and the second value changes sign, so that's going to become a negative 3. I would have negative 4, 6. Again, the second value changes sign, so it becomes negative. And lastly, negative 2, 2. This would become negative. And so my new shape would be right here. For the second composition, first I'm going to translate and then I'm going to reflect. So again, I want to write down my original points. E is at negative 7, 6. F is at negative 4, 7. G is at negative 2, 4. And H is at negative 8, 2. When I translate, remember I just can either put my pencil on the point and count, or I can go through and actually do the addition or subtraction. So I'm going to just do this algebraically so that I don't have to graph. So for E prime, negative 7 plus 2 is negative 5. 6 minus 3 is 3. For F prime, negative 4 plus 2 is negative 2. 7 minus 3 is 4. For G prime, negative 2 plus 2 is 0. 4 minus 3 is 1. And for H prime, negative 8 plus 2 is negative 6. And 2 minus 3 is negative 1. If you were to graph those points, it should just have appeared on the graph for you. You'll notice that a few of them overlap, and that's completely okay. Again, if you look at the next transformation, you'll notice the double prime, which means that we are going to use these points and not the original points. So if we're going to reflect over y equals negative x, the rule is that they switch spots and they also change sign. So for E double prime, I would switch spots, so I would have 3, negative 5, and then they're also going to change sign. So it would be negative 3, positive 5. For F prime, they switch spots, they change signs. For G prime, they switch spots, they change signs. And for H prime, they switch spots, and then they change signs. Once you plot this shape, it looks like this. Just make sure you're labeling with the double prime. For my next composition, I noticed that there are 3 transformations. To begin, I'm going to start by writing down each of my original points. M is at 1, 2. N is at 1, 6. O is at 4, 6. P is at 4, 3. My first transformation is a 270-degree rotation. When we do 270-degree rotations, we do 90-degree rule 3 separate times. The 90-degree rule is negative y, x. The first time I use this rule, they switch spots, and the first value changes sign, so I get negative 2, 1. The second time I use this rule, they switch spots, so 1, negative 2, the first one changes sign. And the last time, again, they switch spots, the first value changes sign. If I focus on the first and last point, I can figure out a rule so that I can skip all the middle steps. So I notice that they switch spots, and the second value changes sign. So if I apply that rule, they switch spots, the second value changes sign. Again, switch spots, the second value changes sign. So what would you get for the value of the last point when you use this rule? You should get 3, negative 4. I'm going to write these points under the rotate 270 degrees. So for n prime, I got 6, negative 1. For m prime, I got 2, negative 1. For o prime, I got 6, negative 4. And for p prime, I got 3, negative 4. I'm not going to graph each transformation because my graph will be very cluttered by the end. So for the next one, I'm going to translate x minus 1, y plus 2. I'm going to do this algebraically since I'm not graphing, so I would want to subtract 1 from each x value and add 2 to each y. So for n double prime, I would get 5, 1. For m double prime, I would get 1, 1. For o double prime, I would get 5, negative 2. And for p double prime, I would get 2, negative 2. If I focus on my next transformation, I notice that I have to reflect over the line y equals negative 1. In order to do that, we have to graph our previous points. So graphing those, 5, 1 is n double prime. 1, 1 is m double prime. 2, negative 2 is p double prime. And 5, negative 2 is o double prime. Then I want to draw in the line y equals negative 1. So if I go to where y is negative 1, it's this point here. If I want to draw a line through that, it would have to be a horizontal line. In order to do this transformation, I'm going to put my pencil on one of the points. So I'm going to start with 0 double prime, and I count to the line. So it's 1 away. I want to count the same distance over the line. So 0 triple prime would be at 5, 0. I would do the same process for n double prime. So I start at n double prime, I count to the line, so it's 2 away, and I want to count the same distance over the line. So n triple prime is at 5, negative 2. Pause the video and repeat this process for the other 2 points. The 2 remaining points are listed now, and I've also graphed the final shape, which I'm going to shade in to make it a little easier to see.